So if you've ever worked with survey data, you know there's a step that's absolutely critical but often overlooked: using survey weights. Honestly, it can be the difference between data that really tells you something true about the world and data that's, well, a little bit warped. In this explainer, we're going to break it all down. Think about it. You've done all the hard work. You've collected your survey data. You've run the numbers. But is the picture you're looking at a true mirror of the population you're trying to understand? Or is it more like one of those funhouse mirrors, where everything's stretched and distorted? A lot of the time, raw survey data looks exactly like this unbalanced scale. And that's usually because of something we call the response rate problem. It just means that even if your survey is perfect, some groups of people are simply more likely to answer it than others, and that can really throw your results out of whack. So here's what we're going to cover. First, we'll dig into this unbalanced survey problem. Then, we'll see how weights help us balance those data scales. We'll do a practical walkthrough of how to turn weights on and off, peek under the hood at how they're calculated, and wrap up by talking about why they're a powerful tool, but not some kind of magic wand. Okay, let's dive right into the heart of it all. Why can raw, unweighted data be so darn misleading? Understanding this is key because it's the whole reason survey weights even exist. So here's the thing. It's just a fact that some groups are harder to get a hold of, or maybe they're just less interested in filling out a survey. A great real-world example of this comes from surveying church members in the US. It turns out responses from members in Utah would just pour in at a much higher rate than from other states. Now, if you didn't adjust for that, your data would suggest that the views of Utah members represent everyone, and that's just not the case. Okay, so we've got the problem down. The data scales are tipped. How do we fix it? How do we balance things out and make our data a better reflection of reality? And that's where survey weights come in. Think of them like a statistical correction. If a certain group didn't respond enough, they're underrepresented, the weight basically gives each of their answers a little more oomph. It weights them up. And if a group responded too much, they're overrepresented, the weight dials their influence back a bit. It weights them down. And this is what we're aiming for. We want to go from that skewed, unbalanced picture to this one, where the scales are perfectly balanced. The weight corrects our samples so it looks a lot more like the actual population we're studying.
Okay, so the theory is cool and all, but how do you actually use this stuff? Let's get practical. We're going to see how you apply these weights in a statistical program. Think SPSS or its free cousin PSPP.
Believe it or not, it's actually pretty straightforward. You just go up to your data menu, find the option for weight cases, and a little box pops up. All you do is find your weight variable. This one is conveniently named survey_weight, and pop it over to the other side. And bam, once you hit OK, your program usually gives you a little heads up right at the bottom of your screen. See it there? Weight by survey_weight? That little message is your confirmation that from now on, any analysis you run is going to be properly weighted. All right, let's look at the magic, the before and after. On the left, weights are off. See those nice, clean, whole numbers? That's the raw count of people. Now, look to the right, with the weights turned on. Two big things happened. The counts now have decimals, which looks weird but is normal, but more importantly, check out the percentages. The yes responses just dropped from 59.4% down to 56.1%. That's the weight doing its job.
Okay, this is super important. If you remember one thing, make it this. When you report how many people were in your survey, your sample size, or N, you always use the unweighted whole number. That's how many people actually took your survey. But for pretty much everything else, the percentages, the averages, all the good stuff, you need to use the weighted numbers. That's where the real story is.
So what does that look like in practice? When you're writing up your results, it'll look just like this. You report the more accurate weighted percentage. That's the 56.1%. But right next to it, you put the unweighted sample size. This is perfect because it gives your reader the most accurate finding while also being totally transparent about how many people you actually talk to. Now, you might be wondering, how on earth are these calculated? The good news is you probably won't have to do this yourself. Big data sets usually come with the weights already made, but understanding the logic behind it all really makes the concept click. So let's take a quick peek under the hood. At its core, the formula is shockingly simple. To get the weight for any group, you just take that group's percentage in the actual population and you divide it by their percentage in your sample. That's it.
Let's break it down with an example. Let's say we know from census data that the U.S. population is 49.2% male. But, in our survey, we only managed to get 40% men. All we do is divide the real number, 49.2, by our sample number, 40.
And you do that little bit of math, and you get a weight of 1.23 for males. Because that number is bigger than 1, it tells us we're weighting up every man who responded. We're giving his answers a bit more power to compensate for the men who are missing from our sample. And for females, well, it's the flip side. Let's say the population is 50.8% female, but our sample was 60% female. We got too many. That gives us a weight of about 0.85. Since that's less than 1, we're weighting down each female respondent to correct for the fact they were overrepresented. Okay, last section. And this is really important to remember. Survey weights are an amazing tool, but they are not magic. They have some real limitations and nuances that you absolutely have to be aware of. And this is probably the biggest catch. Weights can adjust the proportions, but they cannot magically create new people. If your sample has 1,800 women and only 200 men, a weight can make the percentages more accurate. But at the end of the day, you're still only working with the opinions of those 200 guys. A weight can't save a really skewed sample.
Something else you need to be aware of is that there are different kinds of weights. What we've been talking about are normalized weights. They just adjust the proportions. But sometimes you'll run into something called raw weights. These are dangerous because they blow up your sample size to match the whole population. You do not want to use those for standard analysis.
And wow, look at this. This shows you exactly why that's so dangerous. On the left, we have a real sample size of about 29,000. On the right, after applying one of those raw weights, the software thinks we have a sample of over 258 million people. With a number that huge, basically every test you run is going to come back as statistically significant, which is just totally misleading. So stick to the normalized weights.
So we've seen how this one adjustment, a weight, is so vital for getting our data closer to the truth. And it really brings us to a bigger question, right? What other invisible forces, what other quiet assumptions are out there shaping the numbers and statistics that we all rely on every single day?